Our hopefully for tonight is pages 586 all and pages 606, 607 odds only. Once again, the hopefully for tonight pages 586 all and pages 606, 607 odds only. Last night you did evens. Tonight you're doing odds. Ain't that odd? Okay, right? Oh my goodness. No, I was thinking something else. Your phone? Team up with someone? Nice. Okay. All right. As you're sending those warm-ups in, our objective for today, I can identify arithmetic and geometric sequences. And by now, I think we're familiar with most of this. And if you notice, when you did the home play over the weekend, just to refreshen up in regards to arithmetic and geometric sequences from Algebra 1, it really helped out when we got to these now with a couple of extra things that we covered yesterday, yes? Okay? So, with that said, let me forward your screen. All right, so once again, our objective for today, I can identify arithmetic and geometric sequences. Without looking at your notes, send me a definition. I don't need an example, non-example, or hashtag. You got 1 minute. Type it in there. All right. 10, 9, 8. What? Oh, 8, 9. No. 8, 7. 7, 6, 5, 4, 3, 2, 1. Well, I see a lot of you, a list of numbers, patterns, list of numbers. Some of you, IDK. Come on now. By now you should know. We've been on this like for ever. All right. So thank you. Let's see if it looks something like this. Did you type in something like that? Yeah, just the definition. Yeah, let it go. All right. We there? All right. So do me a favor and yes, close your notes really quick. Yesterday we said that we needed to learn those forms. Is that correct? Yes. You cannot just copy from your friends, your home play, and expect to do well. From this point forward, I'm going to be doing some pop ones like quick, like today, often, to see how often you're doing your home play. I'm telling you, I got this. All right, so we covered these. We started with these. We went to these. From there to this. We said those were explicit, but those were given. From there, we went to recursive, this one and this one. From there, we did some practice. I gave you guys some patterns. And we went to explicit, and then we went to this and this. From there, we went to some practice ones, which were these and these. and then also identifying one that's the hundredth. And then we figured out that the one, when they ask us for an extraneous number, we usually use the explicit form, okay? So from there, like I said, this is what we need, and this is what you need to know. All these four. All these four. Now, I'm going to focus right now, and we already finished recursive. Don't worry about recursive for right now. I'm going to focus on explicit. And there they are. Yesterday's lesson, if I can recall, I gave you guys sequences, and then from there we started labeling the first one number 1, the second one number 2, and so on and so forth for each term. You guys remember that? Which means these forms work only if we start with term 1. Now let me show you what I mean. Look up to the screen. Damn, did I just rhyme? Let me show you what I mean. Look up to the screen. So if I gave you the pattern 5, 10, 15, 20, I said make it into a table. You guys remember that? And then we started n, f of n. And then we label this one 1, 2, 3, 4, and so on and so forth. So once we find a consistent pattern, it's either going to be in arithmetic, if they're adding or subtracting, or geometric, if they're multiplying or dividing. But that only works if we start with term 1. So, what does that mean? That today, I don't know if you noticed in last night's home play, some of those you started with term 0. You guys notice that? Okay, it's fine if you wrote it using these two, that's fine. I anticipated that. But today, we're going to crank it up a little bit more for those that start with term 0 instead of term 1. So if we have an explicit rule for arithmetic and geometric starting with term 0, this is the form. F of n equals f of 1 plus d times n. And for geometric, f of n equals f of 1 times r to the nth power. Copy those, only the ones on top. You have these ones already. These, copy those. I'll give you some time. So once again, here goes a recap. These bottom ones, explicit rule, today we're focusing on adjusting these. Yesterday we said that when I gave you a sequence and then you made it into a table, we started with term 1 and I gave you these forms. This works when it's the term starting with 1 and up. But they do not work if the term, if the term starts with 0 term. What does that mean, Mr. Q? Well, last night's home play, remember, some of the tables started with 0, 1, 2, 3, and f of n. So if they start with 0 term, then you're not going to use these, you're going to use these. Now, to clarify also, we know that this is not f of 1, it's not referring to f of 1. It's referring to the first term of the entire sequence, which means now that would be this one. And if you want to change these so that you don't get confused, remember, the other way of writing f of 1 or the first term is the letter what? A. That is correct. We can change these to the letter A. Okay? Yeah, so f of 1, you can change it to A because like that, you remember that it talks about the very first term from left to right of the, whatever sequence you're giving us. You good? Yes. Now, I do want to show you the similarities and the differences, and or the differences. Look at the arithmetic from yesterday. It's right here. Look at today, yesterday, today, yesterday, today. Tell your neighbor what's the only thing that changes, please. All right, let's see. Help me out. Huh? Go. Sebastian. Wow. I'm saying, like, what's the difference? What is it? The n, this one's just n, and this one was what? N minus 1. That's the only thing. How about this one for geometric? This was the one from yesterday, and this one from today. Sebastian. Again, the minus 1. This one has it, this one does not. For example, yes? Yes, Mr. Q. All right. Once again, you need to know these. Yes? Because tomorrow, even though it's not Friday, it's Thursday, or it's n minus 1. Whew, that was deep, right? Yeah. All right, copy that one. Example number 5. It reads, given the table of values, write the recursive and explicit rule of the sequence. The table given, we have n. So for the domain n, I have 0, 1, 2, 3, and 4. F of n, which is our range, is 2, 5, 8, 11, and 14. Copy that, and then we'll go over this one together. All right, here we go. Y'all ready? All right, here goes the process that we learned yesterday. The first thing is to make it into a table. Oh, they gave us the table. Second thing is to find a consistent pattern. Which is, very good, plus 3. So if it's adding or subtracting, we know that's a D, which is arithmetic. So they want us to write what? The recursive and explicit. I'm going to start with the recursive. Recursive. Let's see if we remember. Remember that one was the one that you learned from the weekend home play, the video and all that? So we write f of n equals f of n minus 1 plus d. But to make it specifically for this table, what do I need to substitute in there? 3 for d, so I put plus 3. I bring everything else down. F of n equals f of n minus 1 plus 3. All right. That was the easy one. Let's go to the next one, which is the one that we covered today again. We started yesterday. Today, here it goes again. The explicit. All right. So the explicit for arithmetic is f of n equals f of 1 plus d times n minus 1. You're like, wait a minute, Mr. Q. That was yesterday's. Yes. Will it work for this one? Talk to your neighbor, let them know why it will not work for that one. What do we need to do to make it work? That is correct. For today, since we start with a term 0, we need to drop the negative 1 here and just write it as f of n equals f of 1 plus d times n. Javier, can you go back to your sheet? Thank you. So let me substitute all values. We do f of n. I'm telling you, I'm telling you, I got it. Equals to, what's up? No, the other sheet, your real sheet. So this one, we said it's the first term. What is our first term? 2. Very good. 2. It's right here. That's the first term. Yeah, you were gone when I covered that. From now on, this is the first term. Because yesterday we started with 1. Today we start with bam. And then we do, what is d? Plus 3 times n. And this is our explicit form. You guys notice the only difference today is that we dropped the -1 for the rule, and we use, if it starts with a 0 term, we use that as our first term. Can we start computer with these? Okay. 8. I like that. Carlo. All right. Copy this one. See if you can do this one by yourself. I'm going to send you that to your screen, lock your toolbar, and send it in as soon as you are done. Lock it, please. Copy and go. All right, as you send that in, I'm going to go over the process to make sure we got it. Here it goes. First things first, we check to see if there's a consistent pattern. Is there? Yes. Yes, what is it? So we multiply times 2, which means it's not a D, it's an R. Which means this is a geometric sequence. So let's find both. We need the recursive, which is the easy one, recursive. So we write f of n equals f of n minus 1 times r. But we substitute which value for r? 2. So this is f of n equals f of n minus 1 times 2. And this is our new form for recursive. All right, let's go to explicit. Let's see. F of n equals f of 1 times r. However, do we start from term 1? No. From 0, so that means we only put the n term. Do we need to put n minus 1? No. Let's substitute values. F of n equals, what is our first term here in the whole, starting from left to right? 3 times, what is r? R is 2, and then we write the nth power. Now, some people ask me, Mr. Q, can we multiply the 3 and the 2 just to write it as 6n, 6 to the n? I said, well, let me see. Let's ask our order of ops. Please excuse my dog, Aguasapo. No. Oh, my grandfather, one time when I was younger, he got us a little husky. And then he said, give it a name. And me, wanting to be very respectful, I said, Papa, you give it a name. He's all, really? I'm like, yeah. He's all, Aguasapo. Oh, well. So, Aguasapo means a water toad. Anyways, so we can multiply this because it goes out of order. Okay. All right. So let's do one more. Copy this one. Example 5 super Q. See how you do with that one. 5 super Q. Once again, given table is n for the input or all domain is 0, 1, 2, 3, 4. Output is f of n, -7, -2, 3, 8, and 13. Copy that and write your recursive and explicit rules. Copy that and go. All right, we should have some Jedi Masters in the crowd. Very good. All right. So let's see. Some Jedi Masters. Let me send you the last problem. And it reads, example number 6 on your screen. And it says, the graph shows how the cost of personal transporter tour depends on the number of participants. Write an explicit and recursive rule or rules for the cost of the tour. Then calculate the cost of the tour for 12 participants. First thing I need from you is to copy the graph, please. Copy the graph. And let me zoom in. Let me zoom in. All right. The graph shown has, for our x values or n values, it goes all the way from 0 up to 10 by 1. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And on the y values or f of n values, it goes from 0 to, I see it's 300, and it goes by, every tally is 25, is that correct? 2550, 7500, 125, 150, 175, 200, 250, yes, 250. All right, and the points given are here. This one is here, 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 here. I'm not going to say them out loud. I want to see if you can actually read the points. However, think about it. In order to get a recursive and explicit rule from there, what is the first thing you would do? Talk it over to your neighbor. What is the first thing you would do? All right, let's see. Sebastian. What? First thing we would do. Chloe. Make a table. Bam. Let's go. Here, let me help you out. Here goes. There you go. Yeah, that's why it's called a T table. All right, n, f of n. Okay, look up. However, what is my first value that I write right here? Ramon. That is incorrect. Tell your neighbor why that's incorrect. Because the points start at 1. So we go 1, 2, 3, 4, 5. All right. Give me the range. Damien, go. 75, 100, 125, 150, 175. All right. With that said, I'm going to give you guys some time to complete that. Find me the recursive, the explicit, and then calculate for 12 passengers. 12 passengers. Let me send you the screen so you can send me a picture of your work. Copy that and go. All right, so there's the answer on your screen. Make sure, remember, for whenever we start with a 1 for the first term, it's n minus 1. So be careful with those. All right? All right, guys. Once again, our home plate for tonight is pages 586 all and page 606, 607 odds only. Bam. Have a good one. See you guys tomorrow. Bye.